This video is for Lesson 8-2, Writing Equations. Learning goals are to write the equation of a line that is parallel to a given line and to be able to write the equation of a line that's perpendicular to a given line. Here again is the diagram of the skate ramp and its railing. Number 1, the equation of the line containing segment BD is y equals negative 2/3 x plus 4. Identify the slope and y-intercept of the line. So the line containing segment BD is this right here. And this is its equation. From this equation, which is in a certain form called slope-intercept form, we can tell that the slope is negative 2/3 and that its y-intercept is at 4. We can see quickly that its y-intercept is here at 4. And visually, we can confirm the slope of negative 2/3 because if you count down 2 units and then right 3 units, you are back on that brown line. So again, this is called slope-intercept form, where the coefficient of x is your slope and the constant term is the y-intercept. Now, number 2. Based on your conjectures in item 4 of the previous lesson, what would be the slope of the line containing segment JM? And use the formula for slope to verify your answer or provide an explanation of the method you used. So the line containing segment JM, that's right here, tracing it in brown. Because that is parallel to segment BD, I can conclude that the slope is also negative 2/3 using what we figured out in the last lesson, that slopes of parallel lines are the same. And so here is my justification because those are parallel. Number 3, identify the y-intercept of the line containing segment JM and use the slope and intercept to write the equation. So JM is touching the y-axis right there, and counting up from the origin, that is at 6. So the y-intercept of that line is 6, which I've written here, b equals 6. Now write the equation of the line. So y equals negative 2/3 x plus 6. To write an equation of a line, put the slope in front of x and put the y-intercept on as the constant. Number 4. If segment JM is perpendicular to segment RJ, identify the slope, y-intercept, and the equation for the line containing segment RJ. So up here in the picture, let's find segment RJ. It is this one right here, from R to point J, touching at a 90-degree angle. These are perpendicular. It asks for the slope. Well, I think that the slope is 3/2, 3/2. The way that I found that was by taking the opposite reciprocal of this slope. Because in the last lesson, we said that perpendicular lines will have slopes that are opposite reciprocals. And it touches the y-axis at positive 6. So our equation is y equals 3/2 x plus 6. We can do a quick visual confirmation that the slope of this brown line is 3/2. From that y-intercept dot at 6, if you rise 3 units and run 2 units, you're back on that brown line. The slope is 3/2. Is segment BD perpendicular to segment RJ? Okay, so BD was this first one that I had highlighted in brown, and RJ was the last one. And if you extend RJ and you extend BD, would they create a 90-degree angle? I think the answer is yes, they are perpendicular. And my confirmation of that is by using their slopes. Negative 2/3 and 3/2 are opposite reciprocals. The skate park will also have an angled grind rail. A drafter is drawing the grind rail on a coordinate plane. So here it is. It's this diagonal line. The drafter has already drawn line N. So this black line is line N. Next, the drafter needs to draw line P so that it is parallel to line N and passes through the point negative 2, 3. So here's the origin. I located negative 2 comma 3. Left to negative 2, up to positive 3, there's the dot. I want to draw a line through that dot that is parallel to this original line. So we have some questions about this. What is the slope of line P? What will be the slope of this line parallel to this line? Well, does it make sense that if we find the slope of line N, that line P will have that same slope? And so right here I have found the slope of line N. 3 subtract 1, I'm taking that y-coordinate and subtracting that y-coordinate. And then 8 subtract negative 8. I'm taking that x-coordinate and subtracting that x-coordinate. That's 2 over 16, which simplifies to 1/8. So I think that the slope of line P, when I draw it, will be 1/8. How do I know? Because I used the slope formula. Now question B, what is the equation of line P written in point-slope form? Point-slope form was a way to write equations that you learned in algebra. It's reviewed over here on the side of the screen, and I've written it here as well. Y minus the y-coordinate of a point is equal to m times x minus the x-coordinate of a point. And so let's take that point that we know is on line P. We've already found it here, negative 2 comma 3, and use that for the y1 and for the x1. That creates y minus 3 equals 1/8 times x minus negative 2. That is point-slope form. There's one more thing I could quickly do. This minus negative right here in the middle could be made into a plus sign. So that's why I rewrote it over here in a simplified version. Question C, what is that equation written in slope-intercept form? So we want to make a conversion from y minus 3 equals 1/8 times x plus 2, which is point-slope form. We want to change it into slope-intercept. So first step, let's do the distributive property. 1/8 times x is 1/8 x. 1/8 times 2 is 2/8. 2/8 is the same as a fourth. One more step, we'll add the 3 to get the letter y alone. So we have y equals 1/8 x plus, if we had a fourth and we add 3, that makes 3 1/4. There is slope-intercept form, which is the more commonly used form for equations in algebra class. Finally, sketch line P on the coordinate plane. We'd already found that dot a long time ago, and remember that we were going to use a slope of 1/8. So up 1 over 8. 1, 2, 3, 4, 5, 6, 7, 8. Similarly, I can go down 1 and left 8. 1, 2, 3, 4, 5, 6, 7, 8. The reason for doing that is because if I have more dots, I can create a better parallel line that's more accurate. Here is line P. It's parallel to line N. Number 7. Next, the drafter needs to draw a line Q so that it is perpendicular to line N and passes through the point negative 9 comma 7. So if it's perpendicular to line N, what I know about its slope is that the slope will be the opposite reciprocal of the slope of line N. Line N had a slope of 1/8, so the opposite reciprocal is negative 8. And this line is going to go through the point negative 9 comma 7. So back on the grid, let's locate negative 9 and then comma 7 right there. We're going to draw a line through that dot, and we want it to be perpendicular to those other two lines. Question B, what is the equation of line Q in point-slope form? So y minus y1 equals m times x minus x1. Y minus For y1, we're using a point that is on line Q. And that, remember, is negative 9, 7. So its y-coordinate is the 7. For the slope, we're using the negative 8. And then x minus x1 is the x-coordinate of the point on line Q, negative 9. Once again, even though this is point slope form, which is what it asks for, I might do one step of simplifying, which is to fix that double negative sign in these parentheses here. There's my equation for line Q, and it's in point slope form. Now, because slope-intercept is the more common form, let's change that equation into slope-intercept form. So first thing, just copy that down so you can work with it. Then do the distributive property, because that removes the parentheses, and slope-intercept form has no parentheses. And finally, add the 7 to the other side. So negative 72 plus 7 is negative 65. Here is our equation in slope-intercept form. Sketch this line on the drafter's coordinate plane. So it's going to go through this dot, and the slope is negative 8. So 1, 2, 3, 4, 5, 6, 7, 8, and write 1. If we draw through these dots, we will have made line Q. And it is perpendicular to that one. And because that was parallel to that, it's perpendicular there as well. Number 8. Finally, the drafter needs to draw a line R so that it's perpendicular to line N and passes through the point 8, 0. So back to our picture. 8, 0. From the origin, go over to 8, and then go up or down, nothing. So there's 8, 0. And we want to draw a line through this dot that's perpendicular to line N and line P. So we're asked about this line. What is the equation of this line in point slope form? So y minus the y-coordinate is equal to the slope, that was negative 8, times x minus the x-coordinate. There is point slope form. What is this equation in slope-intercept form? Well, y minus 0 is just y. And we can do the distributive property. Negative 8x, and then plus 64. There is slope-intercept form. And then C, sketch this line. Remember, it was going to go through this dot, and its slope was negative 8. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, and left 1. This line has a slope of negative 8. It was called line R, and it's perpendicular there and perpendicular there. Number 9, describe the relationships among those 4 lines. So looking at that picture, N was perpendicular to Q. N was perpendicular to R. P was perpendicular to Q, and P was perpendicular to R. There were those 4 right angles when those lines crossed. Quadrilaterals can be classified by the presence or absence of parallel lines and by the presence or absence of perpendicular lines. Number 10, which specific quadrilateral is formed by the intersection of the 4 lines, and explain how you know. What quadrilateral is formed by this, and then going across here? Sorry, the line is so crooked. Then going down there, and then that original line. What quadrilateral is that? That is a rectangle. And the way that I know is because it has two pairs of parallel lines and the angles are 90-degree angles. And I've written that answer out right there. Next, we have some check for understanding questions. So I'll pause the video. In this lesson, we wrote equations for lines that are parallel to a given line. We wrote the equation in two forms, first as point-slope form, and then as slope-intercept form. We also wrote equations for lines that are perpendicular to a given line, again in two forms, point-slope form, and then slope-intercept form.